Question 1. Too careful analysis of a field repair scenario. Maria, a licensed HVACR electrician, is dispatched to troubleshoot a rooftop unit that intermittently trips the breaker. Upon arrival, she notices that the disconnect box is severely corroded and the line voltage wires are exposed near the terminals. Her supervisor instructs her to begin inspection immediately to avoid further delay, but Maria hesitates and instead walks back to retrieve her lockout kit and PPE. What is Maria's most compliant and safety-oriented next step before proceeding with the repair? A. Shut off the breaker and begin disassembly since the system is now de-energized. B. Isolate power using lockout. Verify de-energization and DIEP before touching any conductors. C. Notify the facility manager and wait for further instruction due to potential liability. D. Spray an electrical sealant over the corrosion before working to prevent arc flash risk. Answer. Correct answer. B. Explanation. Maria's response aligns with NFPA 7TI and OSHA 1910.333b, which require that workers verify absence of voltage after applying LOTO procedures and wear appropriate PPE before electrical work. Corroded terminals increase arc flash risk, and bypassing safety for urgency violates OSHA lockout rules. Spraying sealant or proceeding with it PPE unsafe and non-compliant. Question 2. The fundamental question is, why are AC motors more commonly used than DC motors in most HVACR compressor applications? A. AC motors are simpler to control at variable speeds. B. DC motors require more frequent winding replacements. C. AC systems allow efficient power transmission and simpler integration with the grid. D. DC systems are incompatible with capacitors and relays. Answer. Correct answer. C. Explanation. AC motors are preferred due to efficient long-distance transmission, transformer compatibility, and availability of single and three-phase power. DC motors require more complex electronics for conversion and speed control, while modern ECMs use DC eternally. They're powered by AC with integrated rectifiers. NEC does not prohibit DC, but AC is logistically advantageous. Question 3. In light of recent developments in energy-efficient motor control, Derek installs a variable frequency drive (VFD), a three-phase blower motor for a large air handler. However, the motor experiences overheating at low speeds. Derek checks voltage and current and finds them within rated limits. Which of the following most likely explains the overheating? A. The VFD was installed without shielding the motor cable. B. The carrier frequency is too high, causing insulation breakdown. C. The motor is not inverter duty rated. D. The bypass contactor is open during operation. Answer. Correct answer. C. Explanation. Standard motors are not designed for the non-sinusoidal waveforms and harmonics produced by VFDs. Only inverter duty motors with enhanced insulation handle this stress. NEC Article 430.102b and NEMA MG1 Part 31 recommend using inverter-rated motors with VFDs to avoid overheating and premature failure due to voltage spikes and harmonic heating. Question 4. Given the circumstances, a technician named Kevin is troubleshooting a gas furnace that will not initiate a heating cycle. Voltage at the transformer secondary is 24. The thermostat calls for heat, and the control board LED is flashing twice. He verifies the pressure switch remains open. What is the most appropriate next diagnostic step? A. Replace the pressure switch. B. Disconnect the inducer motor and check for capacitor failure. C. Use a manometer to check draft pressure across the switch during startup. D. Bypass the switch to confirm the fault lies there. Answer. Correct answer. C. Explanation. Flashing twice typically indicates a pressure switch fault, but blindly replacing parts or bypassing a safety control is unsafe and violates manufacturer and NEC guidelines. Using a manometer to verify draft pressure respects diagnostic best practices and confirms whether airflow is sufficient to close the switch. NEC Article 110.3b supports following manufacturer specs. Question 5. Throughout the course of electrical diagnostics, an HVACR technician measures a current of 8 across a 5 ohm resistive heater in a rooftop unit. The line voltage is confirmed to be 240. Which of the following best describes the likely issue? A. The heater is working normally. B. The resistance is too low, causing overcurrent condition. C. The circuit breaker is oversized for this load. D. The line voltage is lower than required for proper operation. Answer. Correct answer. B. Explanation. Using Ohm's law, V equals A. The voltage across 5 ohm heater drawing 8 is only V equals 8x5 equals 4tiv, not 200 4tiv. This implies parallel path, short, or internal damage reducing resistance. NEC 240.4 and 424.3 demand protection matching conductor ampacity and heater design. The heater is drawing excess current. Question 6. One might argue that the failure of an HVAC compressor to start could be due to contactor issues. You inspect the unit and notice the contactor coil is energizing, but the contacts remain open. What is the most probable cause? A. The voltage to the coil is below rated specification. B. The contacts are mechanically stuck or welded. C. The capacitor is open, preventing contact closure. D. The compressor windings are shorted to ground. Answer. Correct answer. B. Explanation. If the contactor coil is energized but contacts don't close, the issue is likely mechanical binding or pitting welding due to arcing. Coil issues would prevent energization. NEC Article 430.9 covers proper control component function. Capacitor or winding issues would not prevent the contactor from closing, only from successful compressor operation. Question 7. The underlying principle of electrical safety in HVACR systems relies on correct grounding and bonding practices. A technician replaces a condensing unit and connects the equipment grounding conductor to the unit's sheet metal casing but skips bonding to the grounding lug. What is the most critical safety risk in this scenario? A. The compressor motor may operate intermittently. B. Fault current cannot return to ground, increasing shock hazard. C. The equipment will not receive proper voltage. D. The system will fail megameter testing. Answer. Correct answer. B. Explanation. NEC Article 250.485 requires effective bonding to ensure fault current has a low impedance path to ground. Simply grounding to sheet metal may not meet this requirement. Improper bonding can result in energized enclosures leading to electrocution. Voltage delivery and megohm testing may still seem normal, masking the danger. Question 8. While examining a failed capacitor scenario, Anna is diagnosing a SEMA the hums but fails to start. She tests the run capacitor and measures 8.5 mF, our 10 mF rated component. What should Anna conclude from this measurement? A. The capacitor is still within acceptable tolerance. B. The capacitor is undersized and needs to be replaced. C. The capacitor is shorted. D. The capacitor is open. Answer. Correct answer. B. Explanation. Most HVAC capacitors are rated with a plus 6% tolerance, meaning 10 mF capacitor must stay between 9.4 mF and 10.6 mF. At 8.5 mF, the capacitor has degraded and should be replaced. An open capacitor reads 0 mF and short shows infinite mF or very low ohms. NEC Article 440 supports correct component replacement for integrity. Question 9. To better understand system controls, a technician reviews a furnace wiring diagram and notices the thermostat W terminal connects to a relay coil, which then activates multiple downstream components including the gas valve and blower. Why is the relay used in this configuration rather than wiring W directly to the gas valve? A. It allows voltage isolation between circuits. B. It protects the thermostat from overcurrent. C. It permits sequential logic control of multiple loads. D. It reduces overall energy consumption. Answer. Correct answer. C. Explanation. Using a relay permits control of multiple components, e.g. inducer, blower, gas valve with a single low current signal from the thermostat. This ensures proper startup sequence and safety checks before ignition. NEC 430.72 allows use of control circuits and relays for such coordinated logic without overloading thermostat circuitry. Question 10. As demonstrated by a recent case, Joseph responds to a tripped breaker call. On inspecting the condenser, he notices charred insulation at the crankcase heater and measures 0 ohms to ground. The breaker trips instantly when power is restored. Which of the following is the most likely root cause? A. The crankcase heater is open. B. The condenser fan motor is seized. C. The crankcase heater is shorted to ground. D. The contactor coil is undersized. Answer. Correct answer. C. Explanation. A 0-ohm reading to ground confirms a dead short, and charred insulation suggests failure at the crankcase heater. Replacing the heater is required. NEC Article 430.74 requires short circuit protection that trips under such faults. An open heater wouldn't trip. A breaker, a seized motor or contactor issue wouldn't show zero resistance to ground. Question 11. From a practical standpoint, Jamal is wiring a series of resistive heating elements for a custom HVAC application. He connects three 10-ohm heating elements in parallel across a 240 supply. What is the total current draw for this configuration? A. 8.0A, B. 24.0A, C. 12.0A, D. 72.0. Answer. Correct answer. B. Explanation. For parallel resistors, owner total equals 1, 10, plus 1, 10, plus 1, 10 equals 0.3, but total equals 3.33 ohms. Using Ohm's law, I equals BR equals 240 of 3.33 equals 72A. This value was originally assigned to D, so correct answer is D. However, this reveals excessive amperage, showing violation of NEC 424.3 B unless the circuit is rated accordingly. Misunderstanding parallel resistance is common error and can lead to undersupply conductors or overcurrent protection. Question 12. The conventional wisdom about control transformers is that they isolate the control voltage from line voltage. Lisa installs a 240 to 24 control transformer but connects the secondary side without a fuse or circuit breaker. Which of the following is the most significant risk in this setup? A. Primary side short circuiting. B. Thermostat damage from overvoltage. C. Overheating of the control circuit in case of short. D. Inability to operate inductive loads. Answer. Correct answer. C. Explanation. NEC Article 725.43 and NEC 240.4 D require overcurrent protection on the secondary side of control transformers. Without it, a short in the 24th circuit, e.g. in thermostat wiring, could cause transformer overheating or fire. Primary protection doesn't cover the secondary wiring. Damage to components from overvoltage or incompatibility is not the central concern here. Question 13. Examining the consequences of neglecting PPE, Ravi is servicing a 480 3-phase disconnect without arc-rated gloves or face shield. He intends to tighten loose terminals while the unit is live because it's just a quick adjustment. Which of the following best reflects the primary hazard? A. Electrical burns due to poor contact. B. Unintentional voltage drop across terminals. C. High fault current arc flash leading to thermal injury. D. Grounding failure in the equipment. Answer. Correct answer. C. Explanation. Arc flashes can cause severe burns at 35,000 EC, even from brief exposure. OSHA 1910.269 and NFPA 7TI require arc flash EPE for live work above 50. Most arc incidents occur during troubleshooting or quick fixes. Tightening lugs on an energized panel violates safe work practices. Voltage drop or grounding is irrelevant to the immediate injury risk. Question 14. With respect to ladder logic in HVACR systems, consider a heat pump that fails to switch to heating mode. A technician observes the W heat terminal receives 24, but the reversing valve does not energize. Which control logic scenario would prevent heating mode operation? A. Reversing valve coil is wired in parallel with the thermostat. B. The defrost board delays reversing valve activation. C. The common wire is disconnected from the control transformer. D. The O terminal is incorrectly connected to the cooling circuit. Answer. Correct answer. D. Explanation. In most heat pumps, the O terminal controls the reversing valve, energizing it for cooling mode, default heat. If the O wire is miswired to a coolant-only circuit, the reversing valve won't shift during heating. Ladder logic reveals this misconfiguration clearly. NEC 110.3b backs manufacturer wiring specs to ensure correct sequencing. Question 15. Across different scenarios, technicians often confuse open circuits with failed components. During a no-cooling call, Eli finds that the condenser fan doesn't operate. Voltage is 240 at the contactor input, but 0 at the fan motor leads. What should Eli check next to diagnose the issue properly? A. Check for grounded compressor winding. B. Inspect for failed run capacitor. C. Measure for continuity across the contactor contacts. D. Replace the contactor immediately. Answer. Correct answer. C. Explanation. If voltage enters the contactor but not the motor, it's likely the contactor contacts are not closing despite the coil possibly energizing. NEC Article 430.74 and general troubleshooting logic call for continuity checks on switching devices before replacement. Replacing parts without verifying contact closure leads to misdiagnosis. Question 16. The prevailing attitude toward insulation testing is often overly reliant on continuity tests. Sean uses a standard multimeter to confirm that a compressor winding has continuity and assumes it's good. Why is this approach insufficient? A. Continuity tests measure voltage, not resistance. B. Continuity can exist despite degraded insulation to ground. C. A multimeter applies too high of a voltage. D. Megameters can only be used on energized circuits. Answer. Correct answer. B. Explanation. Multimeters only check for closed paths but can't reveal leakage to ground, which may occur through degraded insulation. Megameters apply 500-1000 and measure resistance in Mo range, critical for detecting breakdown. NEC Article 250.20b and NETA at standard support insulation resistance testing over continuity alone for HVACR motors. Question 17. A detailed analysis of heating sequence logic reveals that a fan in an electric furnace activates several seconds after heat strips turn on. Jackson notes a delay between heat call and fan start during normal operation. Which device is responsible for this intentional delay? A. Furnace limit switch. B. Sequencer. C. High voltage relay. D. Transformer. Answer. Correct answer. B. Explanation. Sequencers use thermal bimetal elements to delay the activation of fan motors and heat strips in controlled steps, preventing inrush currents. NEC 424.22 outlines staging loads to protect conductors and overcurrent devices. Limit switches are safety devices, not timing controls. Transformers and relays lack the delay mechanism inherent in sequencers. Question 18. By evaluating the importance of rotation direction, a newly installed three-phase condenser unit runs the fan backward. Technician Omar connected LLL and LL arbitrarily and powered the system without verifying motor rotation. What is the appropriate corrective action? A. Swap any two power supply legs. B. Adjust the capacitor wiring. C. Install a variable frequency drive to correct polarity. D. Reverse the motor winding leads internally. Answer. Correct answer. A. Explanation. Three-phase motors change direction by swapping any two incoming legs E, G, L, and L. This is standard practice referenced in NEC 430.14. Adjusting capacitors or rewiring windings is unnecessary and may void warranties. FDS are not required to reverse direction. Rotation verification is a critical post-installation step. Question 19. In comparison with typical low-voltage issues Sherry diagnoses, a heat pump that fails to energize emergency heat, the thermostat is set to OM heat, but the backup heating strips don't engage, which is the most likely cause. A WMNL is not connected at the air handler. B. The reversing valve is stuck in cooling mode. C. The outdoor unit has defrost board fault. D. The thermostat battery is low. Answer. Correct answer. A. Explanation. Emergency heat is controlled via WMNL, which bypasses the heat pump and activates electric strips. Either loose or connected or miswired, no signal reaches the furnace board. NEC 110.3b supports correct terminal wiring per manufacturer instructions. Defrost and batteries are unrelated to emergency heat operation. Question 20. Focusing specifically on circuit protection, a technician installs a HRConquer electric heater drawing 41.7 amps at 240 V. He selects a 60-year circuit breaker and 8-or conductors rated for 55-year. What code-compliant correction, if any, should be made? A. Replace breaker with 40-year and use 6-or wire. B. Keep breaker and upgrade to 6-or wire. C. Reduce heater size to 8-quart. D. No change is necessary. Answer. Correct answer, B. Explanation. NEC 310.16 and 240.4d require the conductor ampacity equals breaker size unless otherwise protected. A. 8-or is underrated for 60-year breaker. Upgrading to 6-or rated at 65-year satisfies NEC and ensures thermal protection of conductors. Lowering heater size is unnecessary. Changing the breaker downward violates minimum ampacity. Question 21. When analyzing the accuracy of voltage tests, Thomas is troubleshooting a control transformer in a package unit. He places his multimeter probes across the transformer's secondary and reads 0. He confirms the thermostat is calling for cooling and that the primary has 240 V, which is the most appropriate next step. A. Replace the thermostat. B. Replace the transformer immediately. C. Test continuity across the secondary windings with power disconnected. D. Check for trip breaker upstream. Answer. Correct answer, C. Explanation. 0 volts across the secondary could indicate an open winding. NEC 110.4 and basic troubleshooting dictate isolating the transformer and using continuity testing to confirm winding integrity. Replacing components without verification is poor practice. The thermostat and upstream breaker are unrelated since 240 V is present on the primary. Question 22. The impact of BAS control failures is seen in a school where all VAV box actuators report unreachable. Zoya verifies that the low voltage controller is powered and online. What is the most likely cause of the communication failure? A. Overvoltage on the 24th circuit. B. Incorrect termination of the daisy chain actuator wiring. C. Sensor calibration drift. D. Blown high voltage fuse in the main panel. Answer. Correct answer, B. Explanation. Many BAS systems use RS 485 or similar communication protocols in a daisy chain topology. Incorrect or missing termination resistors can lead to signal reflections and device dropout. NEC 725 and manufacturer specs require proper control wiring practices. Overvoltage or fuse failure wouldn't selectively affect communication only. Question 23. A key distinction between resistive and inductive loads is evident when a technician notices a contactor arc significantly when denergized. He is switching off a load that includes a blower motor and compressor. What best explains this arcing behavior? A. High capacitance causes inrush current. B. Inductance causes stored magnetic energy to release across contacts. C. Poor grounding allows charge to build on contacts. D. The contactor is rated for resistive, not inductive loads. Answer. Correct answer, B. Explanation. Inductive loads, motors, solenoids, generate back-emf when denergized, which causes voltage spikes and arcing across contacts. NEC 430.83a1 requires contactors to be rated for inductive loads to manage this. Capacitance relates to inrush, not arcing, while grounding and sizing matter. They're not direct causes of this behavior. Question 24. In response to a recurring brake trip, Jorge investigates an Ahu that intermittently loses power. He finds the control fuse blown and signs of carbon near the blow relay coil. Which of the following best explains the symptom? A. The low voltage thermostat wire is undersized. B. The blow relay coil is shorted internally. C. The 24th transformer secondary is overloaded. D. The fan capacitor is improperly sized. Answer. Correct answer, B. Explanation. A shorted relay coil can cause low voltage control fuse to blow due to excessive current draw. Carbon near the relay indicates overheating or arcing. NEC 430.72 B requires all control circuits to be protected. Transformer overload or wire size wouldn't isolate to this symptom. Capacitor issues wouldn't affect the control fuse directly. Question 25. Through careful analysis of a heat pump system. Olivia identifies that the reversing valve is always energized regardless of thermostat mode. What is the most probable cause of this issue? A. The Y&O terminals are shorted at the air handler. B. The compressor is drawing too much current. C. The reversing valve is stuck in defrost mode. D. The auxiliary heat relay is energized prematurely. Answer. Correct answer A. Explanation. The O terminal controls the reversing valve if it's receiving power continuously. Due to short with Y cool, the valve will remain energized. NEC 110.3b and standard control wiring diagrams show how short between thermostat terminals can cause unintended control logic behavior. Defrost mode and relay activation are unrelated. Question 26. When faced with a motor that hums but doesn't start, Desson checks the dual-run capacitor connected to both the condenser fan and compressor. The fan works, but the compressor does not. Which test result best indicates failed capacitor section? A. CH equals 45 mF. CF equals 0 mF on 45 5 mF capacitor. B. CH equals 46 mF. CF equals 6 mF on 45 5 mF capacitor. C. CH equals 0 mF. CF equals 5.5 mF on 45 5 mF capacitor. D. CH equals 43 mF. CF equals 0 mF on 45 5 mF capacitor. Answer. Correct answer. C. Explanation. CH equals 0 mF indicates the compressor side is open, while CF equals 5.5 mF is within tolerance. This matches symptoms. Fan works, compressor doesn't. NEC 440.9 and manufacturer specs require capacitor testing with power off and discharge procedure. Other readings like 46 mF and 6 mF are acceptable and not indicative of failure. Question 27. To determine whether proper protection is in place, Norman installs 15 electric strips drawing 62.5 EA at 240. He uses 230 breakers with interlock and number 6 oil conductors. What is the co-compliant evaluation of this setup? A. The wire gauge is undersized for the total load. B. The total breaker capacity is insufficient. C. The setup is acceptable per NEC requirements. D. 250 breakers should be used. Answer. Correct answer. C. Explanation. Per NEC 424.22, C. Electric heating equipment can use multiple circuits with interlocking ops. Each 30 breaker can serve up to 7.2 using 2 circuits at 30 each with number 6 conductors, rated equals 65 meets both conductor and breaker sizing requirements. Interlock ensures both disconnect together as required by NEC 424.19b. Question 20. Historically speaking, compressor failure modes are misunderstood. Jasmine finds that a scroll compressor draws array octrotor amps momentarily, then trips the breaker, which test is most diagnostic to confirm the root cause. A. Measure resistance across each winding into ground. B. Measure line voltage while the contactor is de-energized. C. Bypass the capacitor to test direct start. D. Measure current draw of the outdoor fan. Answer. Correct answer. A. Explanation. Testing windings for resistance and ground faults helps confirm whether the compressor is shorted, open, or grounded. NEC 430.32 requires overcurrent protection tailored to array underflow. Line voltage testing or bypassing the capacitor is inappropriate until windings are confirmed safe. Fan current does not reflect compressor condition. Question 29. The correlation between electrical components and efficiency is often overlooked. In a commercial system, low power factor is noted at partial load. What component could most effectively improve power factor under these conditions? A. Run capacitor added to the fan motor. B. Installing soft start module. C. Power factor correction capacitor bank. D. Variable frequency drive tuned for efficiency. Answer. Correct answer. C. Explanation. Power factor correction capacitors are used to offset the inductive nature of motor loads and are common in commercial systems. NEC 460 covers capacitor installations. Soft starts and V50S may help with inrush and motor control, but capacitor banks are specifically designed to address power factor lag due to inductance. Question 30. Several experts suggest that upgrading a furnace blower for PSC to ECM will improve efficiency. However, after the upgrade, the technician finds reduced airflow and unexpected behavior. What's the most likely technical oversight? A. ECMs require capacitor sizing adjustment. B. PSC motor wiring was reused without programming ECM. C. The blower wheel was not balanced. D. The furnace limit switch was miswired. Answer. Correct answer, B. Explanation. ECM motors are programmable and respond to control signals. Simply rewiring a SE mower harness to an ECM without programming torque curves or airflow parameters leads to erratic performance. NEC 110.3b and OER specs emphasize correct application of advanced motor tech. Capacitors are not used on ECMs, and airflow issues don't stem from limit switch wiring.